All right, we have one more factoring technique. Our fourth technique. So far, we have done GCF factoring, we've done difference of squares factoring, and we've done basic FOIL factoring where the leading term is just an x squared or a is 1. So now our last type is what do you do when you have a trinomial, ax squared plus bx plus c, when your a value, the leading term, is not 1. So this is going to involve a little different technique. I have seen this taught to students so many different ways, and depending on who you had for Algebra 1, whether you had Kalkbrenner or Thomas or Sepharadi, you may have learned a way and you may love it. There are some teachers that do what they call the big X method. There are some teachers that do what they call the box method or the AC method. There are some teachers that prefer just to do a guess and check, although I feel like that takes a long time sometimes and it's easier to have a concrete strategy. I'm actually going to show you a way that I just saw, and I thought it was the quickest way that I've seen to this point. I stole this idea from Mrs. Barron, and I'm going to go with that this year and see if it helps kind of streamline the process for you as well. So what I used to do, just to get to show you, is I used to do what was called the AC or the box method. So I would actually break it up and find the AC value and then create a box. I learned this strategy, I'm not sure from which teacher, but this was one that I've tried. So I'm going to try something different this year. If you have a way that you've learned how to do it and you really like it, keep doing it. You do not have to do these a certain way. You do not have to do them the same way I do to be successful. I want you to do what you're comfortable with. But I want to give you another option. So here's what I'm going to do with these. So the first thing you're going to do to factor these is you're going to write down what your AC is. That's going to be taking your A value and your C value and multiplying it together. And you usually, with every strategy, this is usually how you start. So you're going to multiply the A and the C. And then you're going to, kind of like what we did before, think about what two numbers multiply to get 24 and add to get your B value. So what two numbers multiply to get 24 and add to get 11? And you get 8 and 3. So here's what you do with this. You break it down into your parentheses. You're going to put an 8 and a 3, and it doesn't matter which one's which. They're both positive. And then your first term, you're actually going to put the exact same first term in the first slot in each parentheses. You're going to put not a 2x squared. You're going to put just a 2x and a 2x. So you're going to take that same number. You're not going to put these squared, but you're going to put a 2x and a 2x. Here's what we do. This is not your final answer. If you multiply these together, you will not get what you started with. You're going to look at each parentheses and figure out if anything has a GCF that can be taken out. If there is, you're going to divide that out and get rid of it. So here's what I mean by that. In this first one, you have a 2 and an 8. You can divide each of those by 2, giving you x plus 4. This one, I can't do anything. There is no GCF. That is your final answer. So after you go through and write down these two factors, you do have to look at each one. You will have one of them that will have a GCF that we want to factor and basically cancel it away, and you will be left with your answer. And it does not take a lot of work and it does not take a lot of space. So let me show you several of these so you get some practice. Again, if you prefer using a different method, by all means do so. So this one, AC is negative 12 because you multiply the 4 and the negative 3. The two numbers that multiply to get negative 12 and add to get negative 4 are negative 6 and 2. So one parenthesis is going to be 4x minus 6, and one parenthesis is going to be 4x plus 2. So I take this 4 and put that here and here. And then this negative 6 and the 2 are the other term. Both of these actually have a GCF that we're going to cancel out. So 4x minus 6, everything can be divided by 2, so we get 2x minus 3. And 4x plus 2, everything can be divided by 2, and we get 2x plus 1. That is your answer. If you multiply it back together by FOILing, you will get what you started with. And that's a great way to check to see if you're on the right track, is if you get what you started with, you know you're right. Next one, our AC is 49. We're going to multiply the 7 and the 7. So two numbers that multiply to get 49 and add to get 50 are 49 and 1. So we're going to put 7x plus 49 and 7x plus 1. Again, that 7 is going to be that first term. Looking at these two factors, the first one can both be divided by 7. So I'm going to divide everything by 7. I get x plus 7. The second one has no common factor, so we're going to leave it as 7x plus 1. And if you multiply those together, you'll get what you started with. Next one, AC. A times C, 4 times negative 15 is negative 60. Two numbers that multiply to get negative 60 and add to get 4 would be 10 and negative 6. So we are going to have 4x plus 10 and 4x minus 6. I can take a 2 out of both terms, actually. So when I take a 2 out of the first term, I get 2x plus 5. When I take a 2 out of the second term, I get 2x minus 3. And that is the factored version of the original trinomial. Got 2 left. AC here is 12, 4 times 3. Two numbers that multiply to get 12 and add to get 7 are 4 and 3. So I'm going to have 4y plus 4 and 4y plus 3. Does not matter that the variable is different. You still do it the same way. Looking at my two factors, the first one is both terms are divisible by 4. So I'm going to divide a 4 out. I get y plus 1. Next one has no common factors. So I'm going to leave it as 4x plus 3. And that is your factored version. Last one. AC here is 5 times 6 is 30. I need two numbers that multiply to get 30 and add to get negative 17. That is going to be negative 15 and negative 2. So you get 5x minus 15 and 5x minus 2. This first one, everything is divisible by 5, so I'm going to write it as x minus 3 when I divide a 5 out. The second one has no common factors, so I'm going to leave it as 5x minus 2. And if you multiply that back together, you will get what you started with. So there is our fourth and final factoring type. You are welcome to use any technique, any kind of trick that you've learned along the way since Algebra 1. And if you like this one, you're welcome to use this one as your go-to.